This question asks you to investigate models for the population of trout in a lake. Trout is a type of fish. At the start of a year, a lake is estimated to contain 6,000 trout. The owner of the lake estimates that the number of trout will increase by 10% per year. At the end of each year, the owner proposes to remove 500 trout from the lake to prevent overpopulation. Therefore, the relationship between Tn, the predicted number of trout at the start of year n, and Tn plus 1, the predicted number of trout at the start of year n plus 1, is given by this formula. For example, the predicted number of trout at the start of the second year is given by T2 is 1.1 times T1 minus 500. Question A. Use this formula to verify T2 is 6,100. So we just use the formula, substituting 6,041 to get T2 is 1.1 times 6,000 minus 500 is 6,100 as required. Question B. Verify that T3 is 6,210. So we need T3, and we consider n to be 2 to get T3 is 1.1 T times T2 minus 500, which is 1.1 times this value, because it's T2, minus 500, and just using a calculator, we get that it's 6,210 as required. The next, find T4. T4 is what? 1.1 times T3 minus 500, and just using a calculator, it's this value. The next, it is also known that Tn is equal to this. Ci shows that Tn is equal to this. So we need to just simplify this. And how can we do that? You can see that denominator here it's what, 0.1. So we can just consider 500 divided by 0.1, which is what, 5,000, and then expand to get this. So Tn, we can rewrite it as this times 1.1 to n minus 1 minus 5,000 multiplied by 1.1 to n minus 1 and expand to get and plus here, and you can see that it's as required. The next, hence or otherwise find T6. So we can use this formula, just substituting 6 for n to get T6 is 1000 multiplied by 1.1 to the power 6 minus 1 plus 5,000, and just using a calculator, give your answer to the nearest whole number, and it's this, and it's this value to the nearest whole number. The next, after deciding that the trout population would increase too quickly, the lake owner proposes instead to remove 750 trout at the end of each year. The relationship between Dn, the predicted number of trout at the start of year n, and Dn plus 1, the predicted number of trout at the start of year n plus 1, is now given by this formula. It is also known that dn is this, and question di shows that dn plus 1 minus dn is this value. So dn plus 1, it's what is this in terms of dn, so it's 1.1 dn minus, or actually we consider dn plus 1 minus dn, and dn plus 1 is this 1.1 dn minus 750 minus dn, and you can see that it's just 0.1 dn minus 750 and 0.1, and what is dn? It's this. So negative 1500 1.1 to n minus 1 plus 7500 minus 750, and just expand to get what? Negative 150 1 point times 1.1 to n minus 1, and plus 750 minus 750, and it just negative 150 times 1.1 to n minus 1 as required. The next, use the result in part di, this result, to deduce that the predicted number of trout at the start of any year will be greater than the predicted number at the start of the next year. So since 1.1 to n minus 1 is positive, it's because number which is greater than 1 to some positive power, it's definitely it's positive, and hence what? Negative 150 times 1.1 to n minus 1, it's negative, but it is equal to what? Hence it is equal to what? dn plus 1 minus dn, so it's negative, so dn is greater than dn plus 1 as required. Question E. Determine the first year during which there will be no trout remaining in the lake. And it means that dn is equal to 0, so we can consider dn, which is negative 1500 times 1.1 to n minus 1 plus 7500, and just is equal to 0, and we need just solve for n. And you can see that we can divide we can divide each term by 1500 to get 1.1 to n minus 1 is 5, then ln, and it becomes n minus 1 ln of 1.1 is ln of 5, and n is ln of 5 divided by ln of 1.1 plus 1, and it is equal to, just using a calculator, and you can see that it's 17.9 to 3 significant figures. Hence during the 17th year. The next, the lake owner now considers a more general approach where the trout are removed at the end of each year. Let Cn denote the predicted number of trout in the lake at the start of the nth year, where Cn is equal to this. And question F. Find the value of d such that the predicted number of trout at the start of each year is constant. And we can, since it's constant, we can consider that the number for the next year is equal to the number for the current year, and hence it is constant, or because it is constant, we can write like this, and then just substitute an n plus 1 for n into this expression and equating into c, and just solve for d. So it becomes 1.12 n minus 10d 1.1 to n minus 1. It is equal to just this. And we can expand and simplify 1.1 to n minus 10 d 1.1 to n plus 10d is this minus 10 d 1.1 to n minus 1 plus 10d, and you can see that 10d cancels, and we can divide each term by 10, and we can divide each term by 1.1 to n minus 1 to get finally that it's 600 times 1.1 minus d times 1.1 is 600 minus d. Then this to the left, this to the right, and we get 60 is 0.1 d, hence d is 600. The next, to model predicted number of trout, the lake owner has been using sequences generated by this, where dr are positive and r is not 1. And question G use mathematical induction to prove that un is u1 r times r2n minus 1 minus d and multiplied by this, for n is positive integer. So since it's about mathematical induction, as usual we consider n is 1, so we write for n is 1, and the left hand side it's this un is just u1, and the right hand side is this, and substituting 1 for n, we get that it is u1 r to 1 minus 1 minus d r 1 minus 1 minus 1 r minus 1, and you can see that it's what 1 minus 1 is 0, so and it's 1, so it's u1, and as the left hand side is equal to the right hand side, true for n is 1. Then, as usual, assume true for n is k, and we just rewrite this substituting k for n. So uk is u1 times r to k minus 1 minus dr to k minus 1 minus 1 r minus 1, and then we consider n to be k plus 1, so we write for n is k plus 1 and u k plus 1 is, and we should get that it is equal to what, to this, when n is k plus 1. So but it is equal that un plus 1 is this, so we can use this, so uk plus 1 is what, r uk minus d, and substituting uk this, we get that it becomes u1 r to the power of k, because r multiplied by r2 k minus 1 is just r to the power of k minus d r to the power of k minus r. We just multiply this by this r and divided by r minus 1 and this minus d. And we can make just common with common denominator here to get u1 r to the power of k minus r minus 1 here, and we factor out negative d and we get r to the power of k minus r and plus r minus 1, and it becomes u1 r to the power of k minus d r to the power of k minus 1 over r minus 1, and you can see that it is equal to this for n is k plus 1. Hence we can conclude that it's true for n is k plus 1. And conclusion: if true for n is k, true for n is k plus 1. Since true for n is 1, true for any n is positive integer. And that's all for this question.